2.5 million light years away, in a galaxy right next door to our own. A star that once burned about 100,000 times brighter than our sun simply stopped existing. It did not explode. There was no blinding flash, no dramatic supernova lighting up the sky the way massive dying stars are supposed to go out. Astronomers watched it fade, year after year, slowly dimming until it dropped to less than 1/10,000th of its original brightness. And by 2023, it was gone entirely, invisible even to the Hubble Space Telescope. The star did not die the way stars are supposed to die. It simply vanished. And here's the part that should genuinely unsettle you. Scientists now believe this is not some rare isolated glitch. It might be a completely normal way for massive stars throughout the universe to end their lives quietly, without warning, and almost entirely undetectable while it happens. The star at the center of this story has a fairly clinical name, M31 2014 DS1, sitting in the Andromeda Galaxy, our closest large galactic neighbor. A team led by Kishalai Day, an astrophysicist, now at the Simons Foundation's Flatiron Institute, was not even hunting for a dying star when they found it. They were combing through archived data from a retired NASA infrared telescope called NEOWISE, searching for objects that varied unusually in brightness over time. One particular star caught their attention because it brightened suddenly in 2014, and then, starting around 2016, began fading in visible light, slowly and steadily, until it had essentially disappeared by 2023. What made this discovery so significant is that Andromeda is one of the most heavily photographed galaxies in the sky, meaning researchers could pull records from a huge range of world-class telescopes to track exactly what happened to this star, in far more detail than has ever been possible for an event like this before. To understand why this matters, you need to understand what is actually supposed to happen when a massive star dies. Stars significantly bigger than our sun spend their entire lives fusing lighter elements into heavier ones, fighting a constant battle against their own gravity. Eventually, that fuel runs out, and the star's core collapses in on itself in a fraction of a second. Normally, that sudden collapse triggers an enormous rebound, a shockwave that tears through the star's outer layers and blasts them outward in a supernova, one of the most violently energetic events in the entire universe, briefly outshining an entire galaxy. That explosion is not just a dramatic light show, it is the mechanism responsible for scattering many of the heavy elements found throughout the universe, including many of the elements that eventually became part of our own planet and our own bodies. But sometimes, apparently, that rebound simply does not happen. Instead of triggering an explosion, the collapsing core swallows the star's material directly, pulling it inward instead of blasting it outward. Astronomers call this a failed supernova, and for decades it existed mostly as a theoretical prediction, something computer models suggested should happen occasionally, without any solid, confirmed observational proof that it actually did. When Dee's team modeled exactly what happened to M31 2014 DS1, the numbers lined up precisely with that theoretical failure. The star's core collapsed directly into a black hole roughly 5 times the mass of our sun, while only a small fraction of its outer material, roughly 1/10 of our sun's mass, got ejected outward as a faint, slowly expanding shell of gas and dust. No explosion, no fireworks, just a quiet collapse and a star that used to be one of the most luminous objects in the entire Andromeda Galaxy, gone. If a mystery this quietly disturbing is exactly the kind of space story that keeps you hooked, go ahead and hit that like button. It genuinely helps this video reach more people who love this stuff as much as you do. Here is why scientists describe this discovery as genuinely rare, and also why that rarity should make you pause. Based on existing models of stellar death, astronomers had estimated that failed supernovae like this should occur only about once every century in any large spiral galaxy similar in size to our own. Finding one happening in Andromeda, our closest galactic neighbor, essentially right next door in cosmic terms, felt to researchers almost too good to be true. And this was not the first time astronomers suspected they had caught one of these events either. Back in 2009, a research team led by Christopher Kaukonek at Ohio State University identified an earlier candidate, a red supergiant called N6946BH1, that had also seemingly vanished without exploding. But that star sits roughly 10 times farther away than M31 2014 DS1, making it about 100 times fainter and dramatically harder to study in detail. Dee's team found that their model of M31 2014, DS1's collapse also neatly explained many of the previously puzzling observations surrounding that earlier, more distant candidate, essentially giving scientists their strongest, most detailed confirmation, yet that both events represent the exact same rare, quiet phenomenon. Now, here's where the story gets a little uncomfortable, if you actually sit with the implications. If failed supernovae like this really do happen on a regular, predictable basis throughout the universe, it forces a meaningful rethink of how astronomers estimate the population of black holes scattered across every galaxy, including our own. Supernovae are usually treated as the primary mechanism responsible for spreading heavy elements throughout the cosmos, seeding future generations of stars and planets with the raw materials for complex chemistry. But if a meaningful percentage of massive dying stars quietly collapse instead of exploding, they never get the chance to scatter those elements outward at all, keeping much of that heavy material locked away forever inside a newly formed black hole instead. That means our current models of how heavy elements got distributed throughout the universe, including the very elements that eventually became part of Earth, could be systematically off in ways nobody had properly accounted for until now. There's also something worth sitting with regarding just how difficult these events are to actually catch in real time. Unlike a supernova, which announces itself with an unmistakable burst of light bright enough to be spot-to-D from other galaxies almost instantly, a failed supernova produces almost no dramatic signal at all. The star simply fades, gradually and quietly, over the course of years, easily mistaken for countless other mundane explanations. A star simply becoming obscured by dust, or two stars merging together and kicking up a cloud of debris that happens to look superficially similar. Distinguishing a genuine failed supernova from these more ordinary explanations requires exactly the kind of patient, repeated, multi-wavelength observation that only became possible once astronomers had years of consistent archival data covering the exact same patch of sky. Without that kind of long-term monitoring, an event like this could simply happen and vanish without anyone on Earth ever realizing what they had witnessed. If deep dives like this into real, currently unfolding cosmic mysteries are exactly your thing, go ahead and subscribe, because we cover verified space discoveries just like this one on a regular basis, without any of the exaggerated nonsense floating around the internet. Follow-up observations using the James Webb Space Telescope added another crucial piece to this puzzle. Webb detected a faint glowing shroud of gas and dust surrounding the spot where the star used to be, expanding outward at a relatively gentle pace, roughly 100 kilometers per second. Researchers believe this glowing material represents the star's loosely bound outer layers, gently shed just before the core's final collapse, rather than the violently ejected debris you would expect from a genuine supernova. That infrared glow is essentially the only remaining evidence that this star ever existed at all, a faint, cooling remnant marking the site of what researchers now believe is a genuine black hole birth, one that happened almost entirely in silence. It is worth being honest about the remaining scientific caution here too, because not every expert in the field is fully convinced yet. Some researchers, including astrophysicist Griffin Hossenzadeh at the University of California, San Diego, have pointed out that with the relatively sparse observations currently available, it remains genuinely difficult to fully rule out other possible explanations for what happened. No failed supernova has ever been conclusively confirmed beyond all reasonable doubt, and scientists are careful to describe M31 2014 DS1 as an extremely strong candidate rather than an absolutely certain case closed. That kind of careful scientific restraint is actually part of what makes this discovery so compelling. Nobody's overselling it. What we have instead is the most complete, most thoroughly documented observational record ever assembled of a massive star apparently disappearing directly into a black hole. Exactly the kind of evidence theoretical astrophysicists have been hoping to find for decades. Think about what this really means the next time you look up at a clear night sky. Every star up there is, in a very real sense, living on borrowed time, slowly working its way towards some kind of ending. We have always assumed the biggest, most dramatic stars would announce their deaths with an unmistakable, brilliant explosion visible across unimaginable distances. Now we know that is not always true. Some of them may simply fade away instead, quietly collapsing into total darkness, leaving behind nothing but a faint, cooling shell of gas that fades from view within a matter of years. No warning. No spectacular final performance. Just a star that was there and then, one day, simply was not. Its entire violent death hidden behind nothing more dramatic than a slow, patient fade into the dark. It also helps to understand just how strange it is that scientists needed to search backward through years of archived data just to piece this event together, rather than catching it happening live in real time. Astronomers were not staring directly at Andromeda when this star began its slow disappearance. They were sifting through old infrared survey data collected for an entirely different purpose, essentially stumbling across this event years after it had already begun. That means somewhere out there, right now, other massive stars could be quietly working through this exact same process, fading toward invisibility, with nobody currently watching closely enough to notice. We may only ever catch these events by accident, buried inside archives, discovered years or even decades after they actually happened. There is also a deeper, slightly unsettling question hiding underneath all of this. If failed supernovae really do occur roughly once per century in a galaxy the size of our own, then statistically speaking, our own Milky Way has almost certainly experienced events exactly like this one throughout its long history, and will likely experience more of them in the future. Somewhere among the hundreds of billions of stars scattered across our own galaxy, a massive star could already be in the early, quiet stages of this exact same process right now, slowly dimming, its core already unstable, with absolutely no outward sign of the dramatic collapse building toward its eventual conclusion. We simply would not know until we happened to notice the fading, the same way Des' team only noticed Andromeda's vanishing star by accident, buried inside data collected for an entirely different purpose. Researchers are already planning to keep searching for additional examples, expanding their survey to other nearby galaxies with enough archival imaging to support this kind of careful, long-term comparison. Every additional confirmed case strengthens the argument that failed supernovae are not some vanishingly rare cosmic fluke, but a genuine, regularly occurring part of how massive stars end their lives throughout the universe. If that turns out to be true, it means a meaningful fraction of the universe's heaviest, most spectacular stars are ending their existence not with the violent, brilliant explosions we have always associated with stellar death, but with total silence, vanishing directly into darkness, leaving behind nothing but a faint, fading shell and an empty patch of sky where something extraordinary used to shine. It also helps to appreciate just how much technology had to come together to make a discovery like this possible in the first place. Tracking a single star's brightness across nearly a decade, across multiple different wavelengths of light, using data pulled from an entire fleet of different telescopes, including Hubble, the retired Neowise infrared survey, and eventually the James Webb Space Telescope, represents an enormous coordination effort. Each instrument contributed a different piece of the puzzle. Hubble confirmed the star's disappearance in visible light. Neowise's archived data revealed the strange brightening and dimming pattern that first caught researchers' attention, and Webb's infrared sensitivity finally revealed the faint, expanding shell of material left behind, the closest thing to physical evidence this event ever produced. Without every one of those pieces working together, this discovery likely would have remained just another unexplained blip buried somewhere in an old dataset, dismissed rather than investigated. There is also something worth remembering about the sheer scale of what actually happened here, once you strip away the technical language and simply picture it directly. A star roughly 25 times the mass of our sun, burning brighter than almost anything else in its entire galaxy, effectively swallowed itself whole. Not blew apart, not scattered its material outward in a blaze of glory visible from millions of light years away. It simply folded inward, collapsing into an object so dense that light itself cannot escape its gravity, leaving behind only the faintest, quietest trace that it had ever existed at all. That is not a small, incremental scientific finding. That is direct evidence of one of the most extreme, violent transformations physics allows, happening almost entirely without spectacle, hidden in plain sight until researchers finally learned exactly where and how to look for it. For now, astronomers are left with a genuinely unsettling recalibration of how they think about the night sky. Every supernova ever recorded throughout human history represented a star going out with maximum, undeniable drama, bright enough that ancient civilizations sometimes mistook them for new stars appearing out of nowhere. This discovery suggests that, alongside those dramatic deaths, there has likely been an entire hidden population of massive stars ending their lives in complete silence, their final moments never announced, never witnessed, simply erased from the sky without anyone noticing until long after the fact. The universe, it turns out, does not always go out with fireworks. Sometimes it seems it simply goes quiet.